Today, we're going to learn finding the area of a geometric figure using the integration. Consider the area of a triangle with base 2 units and height of 4 units. We all know that the area of any triangle is 1/2 times its base times its height. In this case, we have our area as 1/2 times 2 times 4 is equal to 4 square units. Now remember our answer, since we're going to compare this answer to our next solution. Now let's draw the same triangle in our XY coordinate system. With the same parameters, we have our base as 2 and we have our height as 4 units. Now let's define the function and equations that bound or enclose our geometric figure. Consider this vertical line right here, since this is a line in which x is independent of y. That means for any values of y, we have the same values for our x, and the values of x is constant, which is 2. That's why our equation is x is equal to 2. Now, what about this equation right here? How do we find the equation of that line? To learn more about finding the equation of a line, see my other videos for finding the equation of the line. However, in this line, we can set values for x and for our y. What if our x is equal to 0? Our y is 0. If x is 1, then our y becomes 2. If x is 2, then our y is 4. Therefore, we can conclude by examination that our y is twice our x. Now, we have our equation y is equal to 2x, and let's make this our function f of x. Now, how are we going to find the area using integration after we found the function that bounds the figure? In this case, this is our function. Now, let's consider drawing an infinitesimal rectangle created from our triangle with base dx. Let's enlarge this one. This is our infinitesimal rectangle with a base of dx and with the height of f of x. Now, you might be wondering why the height is f of x when our f of x is not horizontal. This has a slope. Now, in this case, we assume that our rectangle is very small in width, that f of x approximates to being a horizontal line. This one. That means if we make the rectangle very small with a base of dx and with the height of f of x, then the area of that infinitesimal rectangle is equal to the height f of x times the base dx. Now, what if we create infinitely many rectangles, and if we sum all of those infinitesimal rectangles up? Let's draw many. Assume that this infinitesimal rectangle fits the triangle. If we create infinitely many rectangles and we sum all of those infinitesimal rectangles, we can mathematically get the area of the whole region. This one, the region is the triangle. Since integration is the mathematical method for summing up all the rectangles, we then can integrate f of x dx to find the total area of those, or the sum of all areas of those infinitesimal rectangles. And we then integrate our f of x dx and set our lower and upper limits for our base dx. Since our rectangles have bases from x is equal to 0 to x is equal to 2, then our upper and lower limits are 0 and 2 respectively. Now, since our f of x is equal to 2x, because that's the equation of the line, we substitute f of x is equal to 2x to our integral. Now we have our integral of 2x dx evaluated from 0 to 2. Now the integral of 2x is x squared evaluated from 0 to 2, and this is equal to 2 squared minus 0 squared. We have 4 square units, which is the same answer we got using our conventional formula. Now, the purpose of showing this method is because our function, let's say this one, f of x, that bound are to the figure, this triangle, will not always create a regular polygon, as in this case a triangle or a geometric figure with fixed formulas. For example, what if we replace our function with a parabola and set our upper and lower limits to a and b respectively? This is now our new f of x. Notice that we don't have a specific formula for the area of this type of region, and hence we can use the integration method instead. Our general formula for the areas of regions bounded by curves is now the integral of f of x dx evaluated from a to b. Now if you forgot this formula, just remember any rectangle with a height of f of x and a base of dx, and then you multiply base times height, you have a single area of an infinitesimal rectangle, and to take the sum of all those rectangles, you just integrate those areas, f of x dx, evaluate from a to b. Okay, and that's it.